From Australia to Slovenia, this research took place precisely 1 year ago at Renew COE with the support of the Society for Science and Technology. I am Michelle Balasso, a PhD candidate and researcher at the University of Tasmania, and a year ago I was flying over to Slovenia to study the effects of Thermo-Hydro mechanical treatments on timbers grown in Tasmania under a short-term scientific mission. For the study, we employ 3 different timbers, 2 grown in plantations, and a native mix known as Tasmanian oak, which is typically of Tasmanian. The 2 plant species were one Eucalyptus nitens, grown for the production of fiber for the pulp and paper industry, and the other one, Pinus radiata, known as radiata pine, grown for the production of structural material. The native mix was composed by Eucalyptus delegatensis, Eucalyptus obliqua, and Eucalyptus regnans, 3 closely related species of the genus Eucalyptus. We used 30 lamellas, almost of these dimensions, 350 millimeters long, 45 millimeters wide, and 8 millimeters thick, to compress them for a final thickness of 5 millimeters. We used an hydraulic hot press that compressed the timber for 30 minutes, reaching a temperature of 200 degrees. After the testing, we did a whole set of measurements and structural testing to understand how the treatment have impacted the properties of the timber and the final characterization of the various characteristics. Eucalyptus nitens show the largest percentage increase in density, reaching more than 53% respect to the previous density, while radiata pine and Tasmanian oak increased for 43 and 42%. Nitens also achieved the largest compression degree, whilst having the lowest mass loss for 2.43% on average. The dimensional changes were marked for radiata pine samples, which after water absorption test showed more than 50% in thickness swelling due to the high rate of absorption of water. The mechanical test revealed improvements of the structural properties for all 3 species, especially Eucalyptus nitens, which increased markedly in stiffness and in strength. There were no significantly different changes between the 3 species in hardness. These results provide a benchmark for evaluation of thermo-hydromechanical treatments performances on less known species as Tasmanian oak, and species generally utilized for other scopes as for the fiber production. The study has also shown how the quality and properties of such species can be improved through densification to achieve results as good as native timbers or even better than other species as radiata pine. I thank you all for the attention. I hope you enjoyed the rest of the conference, and I want to acknowledge again the support received by the Society for Science and Technology and Renew COE, which hosted me for a wonderful time in Slovenia. Thank you.